Hello, in this lecture we will find the radius of a circle. As you can see in the drawing, we have a circle. Inside the circle we have chord AD that equals to 10 units, and chord BC in the circle equals to 5 units, and the center of this circle is at point O, and we also know that this angle equals to 90 degrees, and we want to find out the radius of this circle. First of all, I will explain to you what is a peripheral angle. Okay, so a peripheral angle is an angle inside the circle its vertex is on the circle, and its curves are chords in the circle. So I will read again the definition of a peripheral angle. So a peripheral angle is an angle inside the circle. Its vertex is on the circle, and its curves are chords in the circle. Okay, so now I will give you an example of a peripheral angle in order to clarify the definition. Okay, so actually a peripheral angle So actually alpha is a peripheral angle because it is inside a circle. The vertex of angle alpha is at point A, and the curve AB of angle alpha is actually chord in the circle, and curve AC of angle alpha is also chord in this circle. Okay, again, angle alpha is a peripheral angle because it is inside the circle. The vertex of angle alpha is at point A, and point A is a point on the circle, and the curves of angle alpha are strings or chords in the circle. Curve AB of angle alpha is string or chord in the circle, and also curve AC of angle alpha is chord in the circle. For that reason, angle alpha is a peripheral angle. And we can also say that angle alpha rests on chord BC. Okay? Angle alpha rests on chord BC in the circle because the curves of angle alpha are on chord BC of the circle. Okay, so angle alpha is an example of a peripheral angle. Okay. In the next step, we will draw a chord through points A and O. You should remember that point O is the center of the circle. So the chord passes through the center of this circle, and we will call the touching point between the chord and the circle point M. So actually chord AM is the diameter of this circle. Again, I will write it down. Chord AM is the diameter of the circle. Okay, chord AM is the diameter of the circle. The red chord AM is the diameter of this circle. And the reason that chord AM is the diameter of this circle is because of the fact that chord AM passes through the center of the circle it is defined as the diameter of the circle. Okay, or I can write that any chord that passes through the center of the circle is defined as the diameter of the circle. So I'll read again what I wrote. Chord AM is the diameter of the circle because of the fact that any chord that passes through the center of the circle is defined as the diameter of the circle, and chord AM passes through the center of the circle, that is to say through point O. And chord AM passes through the center of the circle. That is to say, for point O. Okay, so chord AM passes through the center of the circle, that is to say from point O, that is the center of the circle. For that reason, chord AM is the diameter of this circle. Okay. In the next step, we will connect together by a straight line points M and D. Okay, we connected together by a straight line points M and D. And as you can see from the drawing, angle ADM rests on AM, that is on chord AM, that is the diameter of the circle. Okay, we have rule number 1 that states Rule number 1 states that any peripheral angle that rests on the diameter of a circle any peripheral angle that rests on the diameter of a circle equals to 90 degrees. So I will read rule number 1 again. Rule number 1 states that any peripheral angle that rests on the diameter of a circle equals to 90 degrees. So I will give you an example of a peripheral angle that rests on the diameter of a circle in order to clarify rule number 1. So if chord AB is the diameter of this circle, and for example the center of this circle is at point O, so actually OB is the radius, and also OA is also the radius of the circle, and we have a peripheral angle that rests on the diameter of the circle so actually angle ADC, angle ADB rests on the diameter of the circle, that is to say angle ADB rests on chord AB, that is the diameter of this circle. So according to rule number 1, it equals to 90 degrees. Okay, again, angle ADB rests on the diameter of the circle, that is to say it rests on chord AB, that is the diameter of this circle. For that reason, according to rule number 1, it equals to 90 degrees. Okay, so I write it down. Angle ADB, angle ADB rests on the diameter of the circle. That is to say, angle ADB rests on chord AB, that is the diameter of the circle. Therefore, according to rule number 1, it equals to 90 degrees. Okay. I will write in brackets AB is the diameter of the circle. And angle ADB rests on AB, that is the diameter of the circle. Therefore, it equals to 90 degrees. Therefore, it equals to 90 degrees according to rule number 1. So I will read again what I wrote. So angle ADB rests on chord AB, that is the diameter of this circle. Therefore, according to rule number 1, it equals to 90 degrees. Angle ADB equals to 90 degrees. Okay, so that is the example of rule number 1. Now we will implement rule number 1 in our circle. As you can see from the drawing, angle ADM rests on chord AM, that is the diameter of this circle. Therefore, according to rule number 1, it equals to 90 degrees. So I will write it down. Angle ADM, this angle ADM rests on chord AM, that is to say AM is the diameter of the circle, therefore, according to rule number 1, angle ADM equals to 90 degrees. So I read again what I wrote. Angle ADM rests on chord AM, that is the diameter of the circle. Therefore, according to rule number 1, angle ADM equals to 90 degrees. Okay? Angle ADM rests on AM, that is the diameter of this circle. Therefore, according to rule number 1, it equals to 90 degrees. Okay, so angle ADM equals to 90 degrees. Okay, I write it also here. Angle ADM equals to 90 degrees. According to rule number 1, because it rests on AM, that is the diameter of the circle. In the next step, we will focus on the right triangle ADM. Triangle ADM is right triangle because of the fact that angle ADM equals to 90 degrees. So we'll focus on the right triangle ADM. On the right triangle ADM, we will define angle AMD as alpha, and we will define angle MAD as beta. So angle AMD equals to alpha, and angle MAD equals to beta. That is according to our definition. Okay, again, angle AMD equals to alpha and angle MAD equals to beta according to our definition. Okay, again, angle AMD equals to alpha and angle MAD equals to beta according to our definition. Okay, again, in the right triangle MAD, angle MAD is defined that it equals to alpha and angle MAD equals to beta, according to our definition. We know that the sum of the angles of any triangle equals to 180 degrees, and especially in triangle AMD, the sum of its angles equals to 180 degrees. So actually alpha plus beta plus 90 degrees equals to 180 degrees. So I will write it down. Actually our first equation will be alpha plus beta plus 90 degrees equals to 180 degrees. So our first equation states that the sum of the angles in the right triangle AMD equals to 180 degrees. That is to say, alpha plus beta plus 90 degrees equals to 180 degrees. Alpha plus beta plus 90 degrees equals to 180 degrees. Now we will subtract 90 degrees from equation number 1. We will get that alpha plus beta plus 90 degrees minus 90 degrees equals to alpha plus beta, and 180 degrees minus 90 degrees equals to 90 degrees. Now we will subtract alpha from equation number 1. So we subtracted alpha from equation number 1. We got that alpha plus beta minus alpha equals to beta, and 90 degrees minus alpha equals to 90 degrees minus alpha. So equation number 1 states that beta equals to 90 degrees minus alpha. In the next step, we will define the vertex of the right triangle as point L. So actually in the next step, we will connect together points A and B by a straight line. And we have rule number 2 that states if two peripheral angles rest on the same chord, then they equal to each other. Okay? So rule number one states that if two peripheral angles rest on the same chord, then they equal to each other. So I will read again rule number two. Rule number two states that if two peripheral angles rest on the same chord, then they equal to each other. So if we have two peripheral angles that both of them rest on the same chord, then they equal to each other. I will show you an example in order to clarify rule number two. So in this circle we'll draw two peripheral angles. So this peripheral angle is angle alpha. Angle alpha rests on chord BC. We have another angle that is called angle beta. So as you can see from the drawing, angle beta also rests on chord BC. So both angle alpha rests on chord BC, and also angle beta rests on the same chord BC. So according to rule number 2, because of the fact that those two angles rest on the same chord, that is to say on chord BC, we can say that they equal to each other. That is to say, alpha equals to beta because of the fact that those both angles rest on the same chord BC. Okay, so I write it down. So actually angle alpha rests on chord BC, and angle beta rests on the same chord BC. Okay, angle alpha rests on chord BC, as you can see, angle alpha rests on chord BC, and angle beta also rests on the same chord BC. Okay, so according to rule number 2, they are equal to each other. They are equal to each other that is to say alpha equals to beta. Okay, so according to rule number 2, they are equal to each other, that is to say alpha equals to beta. Okay, so actually I forgot the word R in rule number 2, so I will read it again. If two peripheral angles rest on the same chord, then they are equal to each other. Okay, so those two peripheral angles rest on the same chord BC, therefore they are equal to each other. That is to say, alpha equals to beta. Okay, so we actually can implement rule number 2 in our circle. Angle ABD rests on chord AD. I will write it down. Angle ABD, that is a peripheral angle, rests on chord AD. Angle ABD rests on chord AD. And angle alpha, that is to say angle AMD that equals to angle alpha, rests on the same chord AD. So angle AMD that equals to angle alpha that equals to angle alpha also rests on the same chord that is to say AD. Okay, angle AMD that equals to angle alpha rests on the same chord AD. So I'll read it again. Angle ABD rests on chord AD. Angle ABD rests on chord AD. And angle AMD that equals to alpha also rests on the chord, on the same chord, that is to say on chord AD. So angle AMD that equals to angle alpha also rests on the same chord AD. Therefore, according to rule number 2, if two peripheral angles rest on the same chord, then they are equal to each other. So according to rule number 2, they are equal to each other. That is to say, angle ABD also equals to angle alpha. Angle ABD equals to angle alpha. So I will read again what I wrote. Angle ABD rests on chord AD, and angle AMD that equals to alpha also rests on the same chord AD. It is to say AD. Therefore, according to rule number 1, that states that if two peripheral angles rest on the same chord, then they are equal to each other. So according to that rule, they are equal to each other. That is to say, angle ABD equals to alpha, or angle ABD equals to angle AMD that equals to alpha. Okay, so actually angle ABD equals to alpha. So I write it here, angle ABD equals to alpha. Okay, angle ABD equals to angle alpha according to rule number 2, because it rests on chord AD, and angle alpha also rests on the same chord AD. For that reason, according to rule number 2, angle ABD also equals to alpha, because both of them rests, both of those two peripheral angles rest on the same chord, that is to say on chord AD. Therefore, they are equal to each other. That is to say, angle ABD equals to alpha. Okay, so I marked angle ABD as alpha. Okay, so in the next step, we will focus on the right triangle ABL. So on the right triangle ABL, we will define angle BAL as X. Okay, angle BAL will be defined as X. Okay, so in the right triangle ABL, angle in the right triangle ABL, angle ABL, it is actually angle BAL. Okay, angle BAL. angle BAL okay, in the right triangle ABL, angle BAL equals to x. In the right triangle ABL, angle BAL equals to x. Okay? As you already know, in every triangle in the world, the sum of its angles equals to 180 degrees, and it is especially true for the right triangle ABL. The sum of the angles of triangle ABL equals to 180 degrees. So I'll write it down. That will be our second equation that states that the sum of the angles in the right triangle ABL equals to 180 degrees. That is to say, alpha plus x plus 90 degrees, that is the sum of the angles in the right triangle ABL, will be equal to 180 degrees. So I will write it down. Alpha plus x plus 90 degrees, that is the sum of the angles in the right triangle ABL, equals to 180 degrees. As I already told you, it is true for every triangle in the world, and especially the right triangle ABL. Okay, so we created equation number 2 that states that the sum of the angles in the right triangle ABL, that is to say alpha plus x plus 90 degrees, equals to 180 degrees. Okay, alpha plus x plus 90 degrees equals to 180 degrees. It is true for every triangle in the world. Now we will subtract 90 degrees from equation number 2. So we subtracted 90 degrees from equation number 2. Alpha plus x plus 90 degrees minus 90 degrees equals to alpha plus x, and 180 degrees minus 90 degrees equals to 90 degrees. In the next step, we will subtract alpha from the second equation. We subtracted alpha from this equation, so alpha plus x minus alpha equals to x, and 90 degrees minus alpha equals to 90 degrees minus alpha. So we got equation number 2 states that the angle x equals to 90 degrees minus alpha. Okay, so I'll write it again. Equation number 2 states that angle x equals to 90 degrees minus alpha. Again, equation number 2 states that angle x equals to 90 degrees minus alpha. But we know that actually, according to equation number 1, beta also equals to 90 degrees minus alpha. Okay, this is equation number 1 that states that angle beta equals to 90 degrees minus alpha, so I will write it down. So, according to equation number 1, angle beta also equals to 90 degrees minus alpha. Okay? So, we can deduce immediately from those two equations that angle x equals to beta, but I can show you that it's true in the long way. We will write down that 90 degrees minus alpha equals to 90 degrees minus alpha. Okay, 90 degrees minus alpha equals to 90 degrees minus alpha. The next step, we will subtract 90 degrees minus alpha from this side of the equation by x, because of the fact that x equals to 90 degrees minus alpha. So we can subtract 90 degrees minus alpha by x, and from this side of the equation we can subtract 90 degrees minus alpha by beta, because beta equals to 90 degrees minus alpha. For that reason we can subtract 90 degrees minus alpha by beta. Okay, so we will get that angle x equals to angle beta. Okay, we subtracted 90 degrees minus alpha by x because x equals to 90 degrees minus alpha, and we subtracted, okay, we subtracted 90 degrees minus alpha from this side of the equation by beta, because beta equals to 90 degrees minus alpha. Okay, we got that x equals to beta. Okay, the conclusion is that x equals to angle x equals to angle beta. So we actually can substitute angle x by beta because angle x equals to beta. Yes, angle x equals to beta, therefore we can substitute x by beta. Okay, so angle BAL in the right triangle BAL equals to beta. Okay, Okay, we have actually rule number 3 that states so we know that in the right triangle BAL, angle ABA equals to alpha and angle LAB equals to beta, and angle BLA equals to 90 degrees. Okay, so we actually have rule number 3 that states if two peripheral angles equal to each other, then they rest on equal chords, equal chords or equal arcs So I will read rule number 1 again. Rule number 1 states that if two peripheral angles equal to each other, then they rest on equal chords/arcs. So I will give you an example of rule number 3 in order to clarify the rule. If we have two peripheral angles so this is peripheral angle alpha, and we have another peripheral angle alpha. Okay, we know that those two peripheral angles equal to each other, both of them equal to alpha. Okay, we have two peripheral angles that equal to each other, both of them equal to alpha. As you can see from the drawing, the black angle alpha in the black color rests on chord BC. Okay, angle alpha rests on chord BC, while angle alpha that is in the right color rests on chord EF. Okay, in the red color rests on chord EF. So I read again what I wrote. Angle alpha in the black color, angle alpha in the black color rests on chord BC, while angle alpha in the red color rests on chord EF. Okay, so both angles, those angles equal to each other, both of them equal to angle alpha, and we know that angle alpha in the black color rests on chord BC, while angle alpha in the red color rests on chord EF. They both equal to each other. So according to rule number 3, BC equals to EF, because if you have two peripheral angles that are equal to each other, then they rest also on equal chords. That is to say, BC equals to EF. Okay? So I write it down. So because of the fact that those two angles, those two peripheral angles equal to each other, so according to rule number 2, according to rule number 3, they rest on equal chords. That is to say, BC equals to EF. Okay, I will read again what I wrote. So actually, because of the fact that those two peripheral angles equal to each other, both of them equal to angle alpha, according to rule number 3, they rest on equal chords. That is to say, BC equals to EF, because equal peripheral angles rest on equal chords. That is to say, BC equals to EF. Okay, so this is the explanation of rule number 3 in detail. Okay, we actually can implement rule number 3 in our circle. Angle BAL equals to beta, and also angle MAD also equals to beta. So in the circle we have two peripheral angles that equal to each other. And according to rule number 3, equal peripheral angles rest on equal chords. That is to say, angle beta that rests on chord BC equals to angle beta, the other angle beta that rests on chord MD. So I will write it down, because of the fact that angle BAC equals to beta, and angle BAC rests on chord BC, and angle MAD equals also to beta, and angle MAD rests on chord MD, So because of the fact that those two angles equal to each other, according to rule number 3, they rest on equal chords. That is to say, BC equals to MD. Okay, so and the angle MAD rests on chord MD. So because of the fact that those two angles equal to each other, both of them equal to angle beta. So according to rule number 3, they rest on equal chords. That is to say, chord BC equals to chord MD. So I will read again what I wrote. Because of the fact that angle BAC equals to beta, angle BAC equals to beta, and angle BAC rests on chord BC, angle BAC rests on chord BC, and angle MAD also equals to beta, angle MAD also equals to beta, angle MAD equals to beta, and angle MAD rests on chord MD, angle MAD rests on chord MD, angle MAD rests on chord MD, according to rule number 3, because of the fact that both two angles equal to each other, both of them equal to beta, according to rule number 3, they rest on equal chords. Okay, because of the fact that both peripheral angles equal to each other, they also rest on equal chords. That is to say, chord BC equals to chord MD. Chord BC equals to chord MD. So I will summarize and say that because of the fact that we have two peripheral angles that equal to each other, this angle equals to beta and this angle also equals to beta, then according to rule number 3, they also rest on equal chords. This angle rests on chord BC and this angle beta rests on chord MD. So according to rule number 3, they rest on equal chords, that is to say BC equals to MD. Okay? So the fact that those two peripheral angles are equal to each other, they also both rest on equal chords. The chords that they are rest on also equal to each other. So this angle beta rests on chord BC and this angle beta rests on chord MD, and according to rule number 3, because of the fact that those two peripheral angles are equal to each other, they also rest on equal chords. That is to say BC equals to MD. Okay? So if you have in a circle two peripheral angles that are equal to each other, then they also rest on equal chords. Okay? That is to say BC equals to MD. Because of the fact that they equal to each other, this angle is beta and this angle is beta, they rest on equal chords. That is to say BC equals to MD. Okay? So you can also define that rule number 3, that equal angles rest on equal chords. Those two angles equal to each other, both of them equal to beta, so they also rest on equal chords. This angle rests on chord BC and this angle rests on chord MD. So the chord that they rest on equal to each other. That is to say BC equals to MD. So equal peripheral angles rest on equal chords. Those two peripheral angles are equal to each other, therefore they rest on equal chords. That is to say BC equals to MD. Okay? Again, I defined it a little bit different, but I can also define rule number 3 that it states that equal peripheral angles rest on equal chords. Okay? Those peripheral angles are equal to each other, therefore they rest on equal chords. BC equals to MD. Okay? So we'll write down that according to rule number 3, BC equals to MD. BC equals to MD. So according to rule number 3, because of the fact that those two angles are equal to each other, they also rest on equal chords. That is to say BC equals to MD. Okay, so according to rule number 3, BC equals to MD. But we know that BC equals to 5 units. It is given us in the question. BC equals to 5 units. Okay, so we know this given us in the question that BC equals to 5 units. So from one side BC equals to MD, from the other side BC equals to 5 units. So we can deduce from it that MD also equals to 5 units. Okay? We can deduce from these two expressions that MD also equals to 5 units. Okay, we can deduce from it that MD also equals to 5 units. Okay, we can deduce from these two expressions that MD also equals to 5 units. Okay, so I'll write it down that MD also equals to 5 units. Okay, so now I will draw again the right triangle AMD. So this is the right triangle AMD. Side AD of the triangle equals to 10 units. Side MD of the triangle equals to 5 units. And AM is the hypotenuse of the triangle, and AM is also the diameter of the circle. So we'll define AM as D, abbreviation for diameter. Okay, AM will be defined as D, abbreviation for diameter. Okay, so we have right triangle. We know the value of two sides in this right triangle. The only missing variable is the hypotenuse of this right triangle. So we actually can use the Pythagorean theorem in order to find out the value of the hypotenuse, that is also the diameter of the circle. So first of all, I will write down the Pythagorean theorem. The Pythagorean theorem apply only to right triangles. So I write down the Pythagorean theorem. So the Pythagorean theorem states that in a right triangle, because it's true only to right triangles, in a right triangle the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so I will read again the Pythagorean theorem. The Pythagorean theorem states that in a right triangle, I repeat again that it is true, the theorem true only on right triangles. So in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so we'll apply the Pythagorean theorem in our circle. So according to the Pythagorean theorem, the square of the hypotenuse, that is to say am square, that will be our further question, am square equals to the sum of the squares of the perpendiculars. So that is AD square plus MD square. Okay, that will be our further question. The further question states that the square of the hypotenuse, am square, equals to the sum of the squares of the perpendiculars, that is to say AD square plus MD square. But we know that AD equals to 10 units, MD equals to 5 units, and AM equals to D. Okay, we know that AD equals to 10 units, MD equals to 5 units, and AM equals to D, that is the diameter of the circle. So we can put the data inside the question number 3, and we will get that okay, we substituted AM by 10, we substituted AM by D because AM equals to D, we substituted AD by 10 because AD equals to 10, and we substituted MD by 5 because MD equals to 5, and we got that D square equals to 10 square plus 5 square. 10 square is 100, 5 square is 25, 100 plus 25 equals to 125, so I will write it down. So we got that t square equals to 125. Now we will take a root out of equation number 3. We will get that t equals to root of 125. So we got that the root of d square is d, and we got that d equals to the root of 125, and 125 equals to 25 times 5, so I write it down. Okay, d equals to 25 times 5 equals 25 times 5 equals to 125. Now we can actually separate the root to two roots according to the rule that according to the rule that the root of a times b equals to root a times root b, you can write that so instead of root of 25 times 5, we can write d equals to root 25 times root 5. Okay, instead of d equals to root 25 times 5, we separated the root to two roots, root 25 times root 5, according to the rule that the root of a times b equals to root a times root b, and the root of 25 equals to 5, so I write it down. So root of 25 equals to 5, so we got that d equals to 5 times root 5. As I already mentioned, d is the diameter of the circle, and the diameter of any circle equals to 2 times the radius of the circle. So I write the equality. That will be our fourth equation. It states that the diameter of any circle equals to 2 times the radius. Okay? The diameter of any circle equals to 2 times the radius of the circle. Okay? We can, in the fourth equation, we can substitute d by 5 times root 5, because d equals to 5 times root 5. So we substituted d by 5 times root 5 because d equals to 5 times root 5. Now we will divide equation number 4 by 2. We will get that so we divided equation number 4 by 2 and we got that the radius of the circle equals to 5 times root 5 over 2 units. Okay, the radius of the circle equals to 5 times root 5 over 2 units, or we can write also that r equals to 5.59 units because 5 times root 5 over 2 equals to 5.59. So the radius equals to 5.59 units, or the radius equals to 5 times root 5 over 2 units. Okay, so the radius of this circle equals to 5.59 units, or 5 times root 5 over 2 units. Okay, so that is the answer to the question. Now I will summarize the lecture. So actually we wanted to find out the radius of this circle, and we know that the center of this radius is at point O, and chord AD equals to 10 units, and chord BC equals to 5 units, and we also know that angle ALB equals to 90 units, equals to 90 degrees. Angle ALB equals to 90 degrees. Okay, and we want to find out the radius of this circle. Okay, so first of all we will define the term of peripheral angle. A peripheral angle is an angle inside the circle. Its vertex is on the circle and its curves are chords in the circle. So actually angle alpha is a peripheral angle. First of all, angle alpha is in the circle, inside the circle. The vertex of angle alpha is at point A, that is Point A is also point on the circle. And curve AB of angle alpha is chord in the circle, and also curve AC of angle alpha is a chord in this circle. Chord or string is the same, and actually angle alpha rests on chord BC. Okay, angle alpha rests on chord BC. Okay, so that is the definition of a peripheral angle. Okay, the next step, we draw a chord for point A and O. O is the center of the circle. So we draw a chord for point A and O, and we call the touching point between the circle and the chord point M, and actually AM, chord AM is the diameter of the circle, because of the fact that chord AM passes through the center of this circle, that is to say, it passes through point O, that is the center of this circle. And any chord that passes through the center of the circle is defined as the diameter of the circle. And chord AM passes through the center of the circle, that is to say, through point O. Therefore, AM is the diameter of this circle. Okay, and then we have rule number 1 that states that in any peripheral angle that rests on the diameter of a circle equals to 90 degrees. Okay, so I will show you an example of a peripheral angle. Actually, angle ADB is a peripheral angle that rests on the diameter of the circle, because AB is defined as the diameter of the circle, and angle ADB rests on chord AB, that is the diameter of the circle. So angle ADB rests on the diameter of the circle. Okay, so therefore, according to rule number 1, it equals to 90 degrees, because of the fact that any circle that rests on the diameter of the circle equals to 90 degrees. Therefore, angle ADB equals to 90 degrees. So that is the example of rule number 1. We actually can implement rule number 1 on our circle, because angle ADM rests on chord AM, that is the diameter of this circle. Therefore, according to rule number 1, it equals to 90 degrees. So angle ADM equals to 90 degrees according to rule number 1, because of the fact that it rests on the diameter of the circle. Any peripheral angle that rests on the diameter of the circle equals to 90 degrees. So angle ADM that rests on the diameter of the circle equals to 90 degrees. Okay. Now we will focus on the right triangle ADM. In the right triangle ADM, we define the angle AMD as alpha and angle MAD as beta. Okay, and we created equation number 1 that states that the sum of the angles in the right triangle or AMD equals to 180 degrees. It is true for any triangle on the world. The sum of the triangle of any triangle equals to the sum of the angles of any triangle equals to 180 degrees, and especially the sum of the angles of the right triangle AMD equals to 180 degrees. So we created equation number 1 that states that the sum of the angles in the right triangle AMD equals to 180 degrees. That is to say, alpha plus beta plus 90 degrees equals to 180 degrees. Alpha plus beta plus 90 degrees equals to 180 degrees. And regard that beta equals to 90 degrees minus alpha. That is our first equation that states that beta equals to 90 degrees minus alpha. Okay, we have also rule number 2 that states that if two peripheral angles rest on the same chord, then they are equal to each other. So I'll give you an example to clarify rule number 2. So we actually have two peripheral angles, angle alpha and angle beta. Angle alpha rests on chord BC, and angle beta also rests on the same chord BC. So we have two peripheral angles that rest on the same chord BC. So according to rule number 2, they are equal to each other. That is to say, angle alpha equals to angle beta, because of the fact that they both rest on the same chord BC. Okay, so we can implement rule number 2 in our circle. Because we have angle ABD that rests on chord AD, and we have also angle AMD that equals to alpha that is also rests on the same chord AD. So according to rule number 2, because of the fact that those two angles rest on the same chord AD, they are equal to each other. Therefore, if this angle is alpha, this angle is also alpha. Okay? So we can deduce from rule number 2 that angle ABD also equals to alpha, because angle AMD equals to alpha and it rests on chord AD, and angle ABD rests on the same chord AD. Therefore, angle ABD equals to angle AMD, that is alpha. So angle ABD equals to alpha. Okay, so according to rule number 2, angle ABD equals to alpha. Okay. Now we will focus on the right triangle ABL. It is given us in the question that this angle is 90 degrees. And we know that angle ABL equals to alpha and angle BLA equals to 90 degrees. So we will define angle BAL as X. And in the right triangle ABL, the sum of its angles equals to 180 degrees. So we will create equation number 2 that states that the sum of the angles in the right triangle ABL equals to 90 degrees. So x plus alpha plus 90 degrees equals to 180 degrees. So the second equation states that the sum of the angles in the right triangle ABL equals to 180 degrees. That is to say, alpha plus x plus 90 degrees equals to 180 degrees. Okay, so we got from equation number 2 that x equals to 90 degrees minus alpha. Okay, so according to equation number 2, x equals to 90 degrees minus alpha. But we know from equation number 1 that beta also equals to 90 degrees minus alpha. So x equals to 90 degrees minus alpha and beta equals to 90 degrees minus alpha. We can deduce from it that angle x equals to beta, to angle beta. Okay, very simple. So we can, instead of x, we wrote beta because x equals to beta. So angle BAL, but that we defined as x, equals to beta because x equals to beta. Okay, so we know that in the right triangle ABL we have angle alpha, angle beta, and 90 degrees. But we have rule number 3 that states that if two peripheral angles equal to each other, then they rest on equal chords / arcs. So I will give you, so it is a very simple rule that states that if you have two peripheral angles that are equal to each other, then they rest on equal chords or equal arcs. So for example, if you have two peripheral angles, angle alpha is a peripheral angle in the black color, and angle alpha in the red color also is peripheral angle. So you have two equal peripheral angles. So according to rule number 1, they rest on equal chords. Angle alpha in the black color rests on chord BC. Angle alpha in the red color rests on chord EF. And those two angles are equal to each other, so they rest on equal chords. That is to say, BC equals to EF. So if we have two peripheral angles that are equal to each other, they also rest on equal chords. That is to say, BC equals to EF. Okay, so we can implement rule number 3 in our circle, because we have angle beta BAC is angle beta. It is also angle beta is a peripheral angle, and angle beta here rests, angle beta, angle BAC, that is angle beta, rests on chord BC. Angle BAC, that is angle beta, rests on chord BC. And angle MAD, that is also angle beta, rests on chord MD. So we have one angle that rests, on chord BC, and we have another angle that rests on chord MD. But we know that those two angles equal to each other. Therefore, they also rest on equal chords. That is to say, BC equals to MD. Because of the fact that those two angles are equal to each other, they rest also on equal chords. That is to say, BC equals to MD. Because equal peripheral angles rest on equal chords. That is to say, BC equals to MD. Okay? Again, angle BAC rests on chord BC. Angle MAD rests on chord MD. And those two angles equal to each other. So according to rule number 3, they rest on equal chords. That is to say, BC equals to MD. Okay, we know that those two peripheral angles are equal to each other, therefore, according to rule number 3, they rest on equal chords. That is to say, BC equals to MD. Okay? So, according to rule number 3, chord BC equals to chord MD, but we know it is given us in the question that chord BC equals to 5 units. We know that chord BC equals to 5 units, so we can deduce from it that MD also equals to 5 units. Okay, so chord MD also equals to 5 units. Okay, so I draw the right triangle MAD again. We have side AD equals to 10 units, side MD equals to 5 units, and the hypotenuse of this right triangle equals to the diameter of the circle. So I marked it as D, abbreviation for diameter. We know that also the diameter of any circle is 2 times the radius. We will use it in order to find out the radius of the circle. First of all, in order to use the Pythagorean theorem, first of all I will present the Pythagorean theorem. Actually, the Pythagorean theorem applies only to right triangles. So in a right triangle and only in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So we actually will implement this rule in our circle. The square of the hypotenuse is AM square, equals to the square of the hypotenuse, or equals to the sum of the squares of the perpendiculars. That is to say, AM square equals to AD square plus MD square. Okay? So our further equation is that the square of the hypotenuse, AM square, equals to the sum of the squares of the perpendiculars, equals to AD square plus MD square. But we know that AD equals to 10 units, DM equals to, or MD equals to 5 units. And AM is the diameter of the circle, we marked it as D. So we can put the data inside the third equation, and after we put the data inside the third equation, we got that the diameter of the circle, or D, that is also the hypotenuse of the right triangle, equals to 5 times root 5. But we know that the diameter of any circle equals to 2 times the radius of the circle. So we created equation number 4 that states that the diameter of the circle equals to 2 times the radius of the circle. Okay, but we know that D equals to 5 times root 5. So we can substitute D by 5 times root 5. So 5 times root 5 equals to 2 times the radius of the circle. we divided the question number 4 by 2 and we got that the radius of the circle equals to 5 times root 5 over 2 units, or R, the radius of the circle, equals to 5 times 59 units. Okay, so the radius of this circle equals to 5 times 59 units, so the radius of this circle equals to 5 times root 5 over 2 units. Okay, thank you very much.